All right, let's finish off this section, this lecture, by doing some more examples of how to find extrema on closed intervals. So first of all, I'm going to give you some guidelines for finding extrema on closed intervals, or on a closed interval, rather. So to find extrema, so let f be a function that is continuous on a closed interval AB. Okay. If somebody comes up to you in the bus and they ask you to find the maximum and minimum of a function, then you could follow the following step and you will always be able to find it. So number one is to find the critical numbers of f in the open interval AB. So find the critical numbers of f on the open interval AB. So meaning not including the endpoints. Two, you will evaluate f at each critical number in the interval AB. That will give you the output value. Three, you will evaluate f at each endpoint on AB, the closed interval. And finally, you will look at the least of the values, so you'll compare, and the least of these values is the minimum, and the greatest is the maximum. Okay, so let's do an example. Let's find the extrema of f of x equal to 3x to the 4 minus 4x cubed on the closed interval minus 1 to 2. So notice here, I don't have a picture of this. I mean, I could graph this. It's not too difficult to graph, but we will solve this without having to look at a graph. So the first thing we do by our steps is to find the critical numbers. And by definition from the previous part, what is a critical number? I wrote this all the way up here. Where is it? Yeah. So a critical number is a number for which the derivative is equal to 0. Okay? So the first thing we have to do is find the critical numbers, but to find the critical numbers, we have to take the derivative. So let's find out what the derivative of f is. Well, the derivative of 3x to the 4 is 12x to the 3, and the derivative of 4x cubed is 12x squared. Okay, so that is the derivative of f. And now we have to find out for which values f prime of x is equal to 0. So to find the critical values, we have to find out whenever this is true. But I know what f prime of x is. F prime of x is equal to 12x cubed minus 12x squared. So I could substitute the value of f prime of x into this equation. So that's going to be 12x cubed minus 12x squared equal to 0. So I just have to find out when is it that this is actually equal to 0. Notice here that we could actually factor. So both of these terms have 12s and they have x's. So we take the 12s out and the biggest x exponent, so that's x squared, we take it out. So it's 12x squared times x minus 1. And we simply have to figure out when is this equal to 0. Now, by the principle of zero products, if we have a times b equal to 0, then either a equals 0 or b equals 0 or both. So by this principle, I'm allowed to say, well, 12x squared is equal to 0, and I could solve this equation, and then I could solve the equation x minus 1 equal to 0. Well, to solve the one on the left, I divide both sides by 12. I mean, you could clearly see that the only value that you could plug in here is going to be 0, but if you wanted to actually do it, you divide both sides by 12, so you get x squared equal to 0. You take the square root, you get x equal to 0. On this side, you simply move the 1 over, so you get x equals 1. So when x equals 0 or x equals 1, we have our critical value. So x equals 0 and x equals 1 are our critical values. Now, the second step, once we have found the critical numbers, we have to now evaluate each critical number in f. So that just means evaluate 0, x equals 0 and x equals 1 on the original function f, which is up here. So let me rewrite f. So step 2, we have f of x again is equal to 4x cubed minus 3x to the 4. No, opposite. This is 3x to the 4 minus 4x cubed. And now we simply have to evaluate these numbers at this value. There we go. So if we plug in 0 here, we get 3 times 0 to the 4 minus 4 times 0 cubed. And this is simply equal to 0. So we have that for 0, when we plug in 0 for x, we get 0 for y. So we have, this is what I call a critical point. So it's a critical point. Okay? But notice the important thing here is the y value. We already know the x value. What about f equals 1? Well, for f equals 1, we have 3 times 1 to the 4 minus 4 times 1 cubed. So that's going to be 3 minus 4, which equals to minus 1. So for f of 1, we have minus 1. And again, the critical point here is 1, negative 1. And again, we will be focusing on that y value in a second. What is step 3 from the guidelines? Step 3 is to evaluate f at each endpoint. Okay, let me just scroll up so you can see it. So it's to evaluate f at each of the endpoints. Now, our function goes from negative 1 to 2. So we simply have to now evaluate f at negative 1 and at 2. So f of negative 1 is 3 times minus 1 to the 4th minus 4 times minus 1 cubed. This is going to be 3, and then minus 1 cubed is just minus 1, minus minus is plus, so this is 3 plus 4, which is 7. So we get the critical point here, negative 1 comma 7. Again, this is a critical point. I'm going to keep writing critical point because that's going to be part of our vocabulary. And then the other value on the interval was, I believe, 2. Yeah, it went from negative 1 to 2, so it's going to be 3 times 2 to the 4 minus 4 times 2 cubed. Now 2 to the 4, I believe that's 32. Let's see, 2 times 2 is 4, times 2 is 8. Actually, I'm wrong, 16. 16, so 3 times 16 minus 8, 4 times 8. And then, you multiply by 4. So 8 times 4 is going to be 32, and 3 times 16, that's going to be 48. So we're going to have here 16 as a solution. Okay, so we have 2 comma 16 as our final critical point. Now the final step is to compare them. Okay, so the final step is to pick the least of these values as the minimum and the greatest as the maximum. So we're comparing the outputs of these points. Yes, you could have just simply written them and just compare this without writing them in point notation, in the coordinate notation. But in the future we're actually going to be plotting them, so it's important that you begin to simply just write them down as pair of coordinates or coordinate pairs. In any case, the lowest value is -1 because -1 is less than 0. So the point 1 minus 1 is our minimum, and the highest value is 216. So our minimum occurs when x is equal to 1, and the maximum occurs when x equals 2. Alternatively, you could say the, and again you could say the relative minimum. I'll just say the minimum. The minimum occurs at 1, -1, and the maximum occurs at 216. Okay, so that's one example. Let's do another one for practice. So the next example is going to be, again, we're going to find the extrema. In this case, we're going to have f of x is equal to 2x minus 2x to the 2 over 3 on the interval -1, 3. Okay, so again, the first step is to take the derivative, because we need to find the critical numbers, and the critical numbers occur when the derivative is equal to 0. So that's why the first step is always to take the derivative. Well, f prime of x here is equal to 2 minus, and by the power rule, we have 2 times 2 is 4, so 4 over 3 x, and then remember -1, so minus 3 over 3 is -1/3. Okay, so that's the derivative. Now we have to find out when is this actually equal to 0. So when is that actually equal to 0? Well, let's rewrite this real quick. So this is 2 minus 4 over 3 times wait a second. Oh, I copied this wrong. It's supposed to be at 3, so there's no cancellation. Right, so my apologies. So when you do this, there's actually some cancellation, so you just get a 2 here, not a 4 over 3. That makes life much easier, because then we simply have 2 over the cubic root of x. We want to find out when that is equal to 0. Okay, so from here, what can we do? Well, we can move that 2 over. So if we move that 2 over, we have 2 cubic root of x equal to -2. If we divide by 2 on both sides, you have 2 over cubic root of x equals to just 2. And then we can cross multiply. So we have 2 is equal to 2 cubic root of x by cross multiplying, and then we divide by 2 on both sides. So we have 1 is equal to cube root of x. So we have that. If we cube both sides, we have 1 is equal to x. Okay? So we actually have we have x is equal to 1. All right, so let's see now. So that's our critical number. So now that we have our critical number, we simply have to evaluate it on the function f. So remember, f of x was equal to 2x minus 3x to the 2 over 3. So if we evaluate at 1, we have that 2 times 1 minus, just check. Yeah, that's correct. So we have 2 times 1 minus 3 times 1 to the 2 over 3. That's going to be equal to 2 minus 3, which is simply equal to minus 1. So we have that when we plug in 1 into the original function, we get negative 1. So we have the point 1, negative 1. This is a critical point. Now the interval that we were working on is negative 1, 3. So we also have to evaluate at negative 1 and at 3. F of negative 1 is going to be equal to what? It's going to be equal to 2 times minus 1. And this because of what the function is. So let me just write the function so you can see it. It's 2x minus 3x to the 2 over 3. So it's 2 times minus 1 minus 3 times minus 1 to the 2 over 3. So this is negative 2 minus 3. And now if you square minus 1, you get 1. And then if you find the cubic root of 1, it's just 1. So what I did was I did minus 1 squared to the power 1/3, which is equal to 1 to the 1/3, but that's just 1. That's how I got this 1. In any case, it is equal to negative 5 because minus 2 plus minus 3 is minus 5. And finally, the last value is the last endpoint. The last endpoint is 3. So what is f of 3? Well, that's 2 times 3 minus 3 times 3 to the 2 over 3. Again, that is equal to 2 times 3, that's 6, minus 3. And again, you could do it in this way, where you could do 3 squared to the 3. So that's 9, not to the 3, to the 1/3. So it's 9 to the 1/3. So it's going to be the cube root of 9. And this is actually a number, so we could leave it like that. So this is 6 minus 3 cube root of 9. If you were to use a calculator to compute this, this is roughly negative 0.24. And you could tell that it's not going to be less than negative 5. So here, for this particular problem, the maximum is the first value we had. Actually, no, the maximum is actually this negative 0.24. Hold up, let me check something. Let me just check the derivative. Yeah. Right, so we will say that the maximum is negative 0.24 and the minimum is the lowest value, and the minimum happens to be negative 5. Okay? Cool. I'm going to leave one more problem as an exercise. I'll start the problem for you, but I want you to actually finish it on your own. It's not that difficult of a problem. It's the same type of problem. It's just to find the extrema of f of x equals 2 sine of x minus cosine of 2x on the interval 0 to 2 pi. And again, the first step is always to take the derivative. So here the derivative of 2 sine of x is 2 cosine of x. And the derivative of negative cosine of x is plus sine of 2x times 2 by the chain rule. Because remember, you have a 2x in here. So we have that this is equal to 2 cosine of x plus 2 times sine of 2x. So that's what we have for the derivative. So we have to now, you have to now find what values of x, of f prime of x, make this equal to 0. So that means solving this. That means solving 2 cosine of x plus 2 sine of 2x being equal to 0. Okay? So here you're going to have to use some facts from pre-calc to solve it. So this is why I'm leaving it here as an exercise, especially to simplify this. Okay, you have a 2x in here, so you have to figure out there's a trigonometric rule that allows you to simplify this. So I'm going to leave it at that. And then once you take the derivative and you find what makes this equal to 0, then all you have to do is test it on f. So you're going to plug in here, let's say x1, and then if there's another one, x2, and you'll find your critical numbers. Okay? So I'll leave that as an exercise, and if you have any questions about it, just send me an email. Thank you for your attention.